Hey guys, before we get going in today's lesson, I just want to give a quick reminder to make sure you guys are getting signed up on our Google Classroom page. I'll be sending out another email with the join code for that so that you guys can get on there, as that's where you guys are going to be turning in all of your homework from now on, or at least most of it. We might be still using some other things, but for the most part, we're going to be turning our homework in on that Google Classroom. So make sure you guys get on there so that you can make sure you're getting your homework turned in. So today we're going to be continuing on with Chapter 8. We're going to be doing Lesson 2, which is on factoring using the distributive property. So in the last lesson, we learned about finding the greatest common factor of monomials, writing out their factored forms. We're going to be kind of going a step further now today and showing how to factor different monomials, binomials, really polynomials, which is really just taking monomials and adding and subtracting them in one expression. So some vocab here. Factoring is finding the completely factored form of an expression. So getting it down to its most simplest form. Factoring by grouping, which we're going to get to in some of our examples, is using the distributive property to factor polynomials having 4 or more terms. Zero products property states that if the product of two factors is 0, then at least one of the factors must be 0. Then roots are the solutions of an equation. Now that's important to know because as you move forward in math, when you're solving different polynomials, sometimes it'll tell you to solve the polynomial, sometimes it'll tell you to find the roots of the polynomial. That's really telling you the same thing. You're just trying to find the solutions of that equation. So let's go ahead and get into some examples. First off, we're going to be using the distributive property to factor each polynomial by using, to factor each polynomial. So in order to do that, left the marker over here. In order to do this, this is really, it says using the distributive property, we're really going to be doing the distributive property backwards. In the past, when we've used distributive property, it's something like 2 times x plus 3. We would distribute that 2 into the parentheses, and we would get 2x plus 6. So for what we're going to be doing today, it's going to be working backwards. We're going to be given that 2x plus 6, and we have to factor it back into what looks like the distributive property. So here, 2 times x plus 3. So what we're going to do on this first one, I'm going to show you kind of the long steps of how to do this. So we're going to go back to what we did on Tuesday, and we're going to take our two terms here and write out their factored forms, or the prime factorization of each of them. Now if we take 12 and do a factor tree, we've got 3 times 4. 4 becomes 2 times 2. So we've got 2 times 2 times 3 times a times a. 16. 4 times 4, those each break into 2 times 2. So we're going to have 2 times 2 times 2 times 2 times a. Now, we want to find the greatest common factor between these two terms. Because what we're really doing here to factor this is we're going to find the greatest common factor and pull that out of our polynomial. So again, in order to find the greatest common factor, we've got the prime factorization. We find anything that they share in common. So in this case, they each have 2 sets of 2's and a set of a's that they share. So the greatest common factor would be 2 times 2 times a, which gives us a greatest common factor of 4 times a. So now that we've found that, that's what we did on Tuesday. Today, taking it that one step further, is actually using that greatest common factor to factor it out of this polynomial and come up with our simpler term here. So in order to take 4a out of this, what we're really doing is we're taking our expression 12a squared plus 16a, and we're dividing it by 4a. So for our factored form, to write out the factored form, we're going to have 4a, whatever we're taking out of it, and then in parentheses, we're going to have whatever we're left with when we divide this by that greatest common factor of 4a. So when we divide this, we have to divide both terms by 4a, and if you remember, 12a squared divided by 4a, first you're going to pay attention to the numbers. 12 divided by 4 gives us 3. A squared divided by a, remember when you divide exponents, you're subtracting. This is really a to the first power. So a squared divided by a gives us a. So for that 12a squared divided by 4a, we're left with 3a, plus, we've got our addition right there, 16a divided by 4a, which would be 16 divided by 4 is 4. A divided by a, those cancel out, so it would just be 4. So the factored form of 12a squared plus 16a would be 4a, that greatest common factor that we found, times 3a plus 4. Remember, we got that 3a plus 4 by dividing our original expression by the greatest common factor. Let's do another one here. I'm going to do this one, that longer method again. So 3p squared q. If I write out the factored form of that, it would be 3 times p times p times q. Then I've got 9pq squared, which would be 3 times 3 times p times q, and then 36pq. If I do my factor tree for 36, I can do 6 times 6, which each simplify down to 2 times 3. So here I would have 2 times 2 times 3 times 3 times p times q. Now I need to figure out what they all have in common. For numbers, the only thing that they all have in common is one set of 3's. Then for our variables, they've each got a p and they've each got a q. So in this case, my greatest common factor would be 3 times p times q. So I know for my factored form, for my final answer, I'm going to have 3pq times something in parentheses. Now remember, that something in parentheses is whatever you're left with when you take your original expression or your original polynomial, 3p squared q minus 9pq squared plus 36pq, and we divide that by our greatest common factor. So here, 3p squared q divided by 3pq. The 3's cancel each other out, the q's cancel each other out, and one of our p's is canceled. So when we do 3p squared q divided by 3pq, we're left with just a p. Then we're going to subtract 9pq squared divided by 3pq. 9 divided by 3 gives us 3. P divided by p, those cancel. Q squared divided by q leaves us with a q. Then our last one, 36 divided by 3, leaves us with 12. P and p cancel, q and q cancel. So that would be our final answer. Now I'm going to do one more of these, and I'm going to do this one with a little bit shorter method. instead of writing it all out, if you remember back to Tuesday's lesson, I kind of showed you how to do that shorter method in order to find the greatest common factor. So the greatest common factor of these would be the largest number that goes into 9, 12, and 18, which in this case would be 3. Then we have to look at their variables and see what each one of them shares. These two each have a c to the first power. Here we have a c squared, but c to the first is the highest that they all share, and then they all share a d as well. So our greatest common factor is 3cd, which means that is what will be outside of our parentheses. And on the inside, we again divide each term by that 3cd. So 18 divided by 3, we're left with 6. C divided by c cancels. D squared divided by d leaves us with d. Then 12 divided by 3 is 4. C squared divided by c is c. D divided by d, those will cancel. And then 9 divided by 3 gives us 3. C divided by c and d divided by d both cancel. So this would be our final factored form. That's as simple as we can get it. So that's factoring using the distributive property. Next is going to be factoring using grouping. So when we use grouping, again, just like the definition on that first slide said, this is used anytime we have 4 or more terms. So for this one, what we're going to do, it has 4 terms, so we're going to go ahead and group them together in groups of 2. So we're going to put 4ab plus 8b together, and then we're going to put 3a plus 6 together. So what we do here is we factor each group of terms separately. So 4ab plus 8b, we want to figure out what can we take out of that. So the greatest common factor between these two terms for the numbers is going to be 4. For the variables, they both share a b, so we can take that out. 4ab divided by 4b, we're left with just a. 8b divided by 4b, we're left with 2. Then we are going to add, in this case, let's see, we want to see what we can take out of here. 3a plus 6. What is the greatest common factor there? We know that we can take a 3 out of each of those, and in this case, there is no variable that we can take out of both. So now, 3a divided by 3, we're left with a. 6 divided by 3, we have plus 2. Now the key here, whatever you're left with in these 2 sets of parentheses needs to be the same. So now what we're going to do is we're going to take everything that is outside the parentheses, which in this case is 4b and plus 3, and that's going to become one of our factors. Then we're going to take whatever is inside the parentheses, which again, they need to be the same. They both have a plus 2, so that will be our second factor, and this would be the factored form of this polynomial. 4b plus 3 times a plus 2. What that means is if you were to FOIL this out, you would get right back to what you started with up here at the top. Let's do another couple examples here. So again, we're going to group different sets together. So we're going to group our first 2 together, 6x squared minus 15x. Then we're going to group 8x plus 20 together. So 6x squared minus 15x, the largest number that can come out of both 6 and 15 is 3. And then x is the highest degree of the variable that would go into x and x squared. So when you factor that out, 6x squared divided by 3x, we're left with 2x, minus 15x divided by 3x, which leaves us with 5. Then we subtract, and we do the same thing over here. Largest number that can come out of 8 and 20 is going to be 4. When we divide both of these terms by 4, 8x divided by 4, we're left with 2x. Oh, sorry. I'm going to go back here. When we look at this, when we have subtraction in between, we need to ignore that to start with, because what we're going to do actually is, sorry, I'm going all the way back here. We want to group the negative 8x plus 20 together. So we want to put that parentheses outside the negative. Sorry, disregard what I did over the last minute or so, and we're going to start this back over. So we already pulled out the 3x from 6x squared minus 15x. Now we need to see what can we pull out from negative 8x plus 20, and we know that we need to be left with 2x minus 5. So since we know that this addition needs to turn into subtraction because we need to be left with 2x minus 5, we know we need to pull a negative out of this whole thing. So here we're going to pull out a negative 4. When you divide negative 8x by negative 4, you're left with 2x. When you divide 20 by negative 4, you're going to be left with negative 5. So again, whatever is in the parentheses needs to match here. So now, again, we're going to have, for our factored form, we're going to have two sets of parentheses. The first one is going to be everything outside the parentheses, which would be 3x minus 4. The second one is whatever is left inside the parentheses, which would be 2x minus 5. So let's do one more, because I know that was probably a little confusing with me having to change that up a little bit. Let's do one more that has subtraction in the middle here. So I'm going to go ahead and group these together. If I look at RS plus 5S, there's no number that can come out of both of these, but there is a variable that can come out of both. We can pull an S out of there. RS divided by S leaves us with R. 5S divided by S leaves us with a positive 5. So we have R plus 5 left in the parentheses here. Now on this side, we know that we need to be left with R plus 5. Since we have subtraction there, then again we know that we have to pull a negative out of this. Now here there is no number or variable that we can pull out of 5 and R, but what we can pull out of this to change that sign to a positive is a negative 1. So if we pull a negative 1 out of here, negative R divided by negative 1 gives us R. Negative 5 divided by negative 1 gives us a positive 5. So then for our two sets of parentheses for our answer, we would have S minus 1 times R plus 5. So just make sure that you pay attention to that middle term, whether it's subtracting or adding, and knowing if you need to pull a negative out of there or not. So here, I'm going to go over one more special kind of situation here, which is when we need to use the additive inverse property, which, if you remember, the additive inverse property is just saying additive inverses are two numbers that when you add them together will equal 0. So like 5 and negative 5 would be additive inverses. So here, I'll show you when we would need to use the additive inverse property. So if we factor this out by grouping, 35 and 5, we can take a 5 out of each of those, and then x and xy, we can take an x out. 35x divided by 5x leaves us with 7, minus 5xy divided by 5x leaves us with just y. Then over here, we know that we can take a 3 out of each of these. So we're going to factor out that 3. 3y divided by 3 leaves us with y. Negative 21 divided by 3 is going to give us negative 7. So here, if you look at this, our two sets of parentheses, one has 7 minus y, and the other one has y minus 7. We need to get one of these flipped around so that they are both either 7 minus y or y minus 7. When you're factoring polynomials, you're usually going to have it in the form of like x plus 3 and y minus 2. So I want to get it to where they both say y minus 7. So what I'm going to do in order to be able to switch those around is if I take 7 minus y and I multiply it by negative 1, which means I'm going to distribute that negative 1 to both terms, that's going to give me negative 7 plus y, which I can then change the order of this to give me a positive y minus 7. So by multiplying by negative 1, I was able to get this to go from 7 minus y to y minus 7. Just like up here, additive inverse, 5, I multiply by negative 1, I get its additive inverse of negative 5. So what I need to do here in order to get this 7 minus y to y minus 7 is multiply by negative 1, like we just did over here. But I can't multiply just this by negative 1. I have to do the 5x as well. I have to multiply that entire thing by negative 1. So when I do that, I distribute that negative 1 to each term. So I'm going to have negative 5x times negative 7 plus y. Then I still have the same thing over here, plus 3 times y minus 7. So now, if I flip the order of these, I have negative 5x times y minus 7 plus 3 times y minus 7. So now I have it where everything inside the parentheses is the same. So for my solution here, again, my first set of parentheses is whatever is outside. So in this case, negative 5x plus 3. Then my second set would be y minus 7, and that would be my solution. So again, what we're saying, this is the factored form of this polynomial. So if you were to FOIL this all together, you would get back to your original polynomial. All right, then the last thing we're going to do is solving an equation. So again, solving an equation is finding the roots of the equation. So here, hold on just a second, I need to get my charger. Sorry about that. So what we're going to do here is they've already taken one step out of these problems for us. They already have the problems factored. So as you get further in math, you're going to start with a polynomial like we had on those last few slides, and you'd have to factor it and then solve. Here, like I said, they've already factored these. They already have them as the two sets of parentheses. We need to solve the equation or find the roots and then check our solutions to make sure that they work. So in order to find the roots here or solve the equation, you want to take each set of parentheses and set it equal to 0. Now, if we had something besides 0 on this side, we wouldn't be able to set it equal to 0, but we can here because we have it already set equal to 0. So now we just solve for our variable. Here we're going to add 5 to both sides. We get d equals 5. Here we need to subtract 4. So 3d equals negative 4. Divide by 3. And we get d equals negative 4/3. Now we need to check this to make sure it works. We have to check both of our solutions. So if we check d equals 5, if we do plug 5 in for d, so 5 minus 5 times 15 plus 4 gives us 0 times 19 equals 0, which 0 times 19 is 0, so we would get 0 equals 0. That works. So d equals 5 would be a solution. Then, if we plug in negative 4/3 for d in each of them, we would have negative 4/3 minus 5 times 3 times negative 4/3 plus 4 equals 0. Now, negative 4/3 minus 5 would give us negative 19 over 3. And then in this case, 3 times negative 4/3. If we have 3, or 3 over 1, times negative 4 over 3, we can simplify. Our 3's cancel. We're left with negative 4. So negative 4 plus 4 gives us 0. When we multiply, we would get 0 equals 0. So this solution does work. Now, as we continue on, I'm not going to go through and check every single one, but it is a good idea for you guys to do that just to make sure that you did your math correctly here. So here, again, we already had it set equal to 0, so we could just start with what we had here and set everything equal to 0. For this one, x squared equals 7x. So we can't start by just setting things equal to 0 because we have to have this whole thing set equal to 0. So what we're going to do is we're going to subtract 7x from both sides, which gives us x squared minus 7x equals 0. Now we need to factor this side. X squared minus 7x. What can we take out of both of those terms? The only thing that can come out is an x. X squared divided by x, we're left with x. 7x, or negative 7x divided by x, we're left with negative 7. Now, we can go ahead and set each of those equal to 0. So we can say x equals 0, and we can say x minus 7 equals 0. So here, x equals 0, we've got the answer already. Here we just need to add 7, and we get our solution of x equals 7. Now again, we can plug these in to check to make sure they work. With 0, we would have 0 squared equals 7 times 0, or 0 equals 0, so that does work. With 7, we would have 7 squared equals 7 times 7, or 49 equals 49, which is true. So x equals 7 would also be a solution here. I'm going to go ahead and walk through two more here real quick. 3n times n plus 2 is equal to 0. So again, it's already set equal to 0, so we can go straight from here to just setting each term equal to 0. Divide by 3 on this side. N equals 0. Subtract 2. We get n equals negative 2. Again, you can go back and check to make sure that works. This video is getting long though, so I want to hurry up and finish this up for you. And then this last one, again, we need to have 0 on this side, so we need to add 10x to both sides. We get x squared plus 10x equals 0. Then we need to factor this. We can take an x out of each term, and we're left with x plus 10. Then set each one equal to 0. We get x equals 0, and x plus 10 equals 0. Subtract 10 from both sides, and x equals negative 10. So those would be our two solutions. You should come up with two solutions for each of these problems. So there's your homework for today. Again, you guys will be turning this in on Google Classroom. Please make sure you get on there and make sure you're turning the homework in there instead of emailing it to me from now on.